Ever wondered why the atmosphere is so vital to life on Earth? It's like an invisible shield wrapping our planet in safety. Imagine this: without the atmosphere, what would happen? Daytime temperatures could surpass 100 degrees Celsius. At night, they plummet to minus 150 degrees, freezing cold. The atmosphere keeps Earth's temperature stable for life. And so, it shields us from dangerous cosmic threats, like ultraviolet rays from the sun that can damage DNA, or high-energy cosmic rays from deep space, relentless and harmful. Without it, all life on Earth would be exposed to the void. Radiation would devastate plants, animals, and humans alike. The atmosphere acts as a protective cocoon for our planet. Did you know scientists have uncovered something astonishing? Each year, Earth loses 100,000 to 1 million tons of atmosphere. It escapes into space, carried away by solar winds and heat. Here's the thing: why doesn't the atmosphere thin out? To understand this, let's dive into what the atmosphere is. From space, Earth looks like a glowing blue marble. A faint, shimmering layer wraps it. That's the atmosphere. It's a transparent shield, held tight by Earth's gravity. The atmosphere isn't just one gas, it's a complex mix. Nitrogen makes up about 78%, the dominant player. Oxygen, essential for life, accounts for roughly 21%. Argon takes up 0.93%, and CO2 is just 0.041% in 2025. Trace gases like neon, helium, and methane are also present. Together, they form a perfectly balanced system for life. The atmosphere is divided into 5 distinct layers. First up is the troposphere, closest to Earth's surface. It stretches from 0 to 12 kilometers in height. This is where the air is densest, buzzing with activity. Weather like rain, snow, and thunderstorms happens here. Clouds swirl and form, bringing life-giving precipitation. Next up is the stratosphere, from 12 to 50 kilometers. The air here gets thinner, and convection weakens. The ozone layer resides in this region, and it's critical. Ozone absorbs UV rays, protecting us from skin cancer. It's like Earth's natural sunscreen, pretty incredible. Then comes the mesosphere, from 50 to 85 kilometers. This is the coldest layer, dropping to minus 90 degrees. Meteorites burn up here, creating dazzling meteor showers. Think about it, those streaks of light in the night sky. The air here is mostly nitrogen and oxygen, but very thin. Next is the thermosphere, from 85 to 800 kilometers. Also called the ionosphere, it's a fascinating region. Solar radiation ionizes air molecules in this layer. Temperatures can soar to thousands of degrees, astounding. The auroras we see, vibrant and colorful, form here. The International Space Station orbits in this region too. Finally, there's the exosphere, above 800 kilometers. The atmosphere is extremely thin here, almost vanishing. It gradually transitions into the vastness of space. At 22,000 kilometers, traces of gas can still be detected. The exosphere has no clear boundary, which is remarkable. Gas molecules here are barely held by Earth's gravity. And so, they can easily escape into the cosmos. In 2025, NASA's MAVEN mission revealed something key. Earth loses 100,000 to 1 million tons of atmosphere yearly. Solar winds and thermal escape, or Jean's escape, drive this. But why doesn't the atmosphere just vanish over time? Here's the thing: Earth constantly replenishes its atmosphere. Ocean evaporation pumps thousands of cubic kilometers of vapor. Volcanic eruptions release CO2, water vapor, and sulfur gases. Biological activity plays a huge role in this process. Plants photosynthesize, producing oxygen we breathe. Animals and microbes release CO2 during metabolism. Think about it. Every breath you take adds to the atmosphere. It's a tiny contribution, but it's part of the cycle. Micrometeorites bring water vapor and gases from space. These sources keep Earth's atmosphere in balance. It's a dynamic equilibrium, stable for billions of years. But the atmosphere isn't unchanging, far from it. In 2025, CO2 levels hit 420 parts per million, a record high. Climate change is warming the atmosphere, shifting weather. The ozone layer is recovering thanks to the CFC ban. But methane levels are rising, fueling greenhouse effects. Scientists worrying about the atmosphere's long-term stability. If this balance tips, the atmosphere could change drastically. Imagine Earth becoming like Mars, with a thin, cold atmosphere. Mars once had a thicker atmosphere but lost it over time. MAVEN data in 2025 shows solar winds stripped Mars bare. Earth's magnetic field protects our atmosphere from this fate. It acts like a shield, deflecting solar winds. But Earth's magnetic field is weakening over millions of years. This could pose risks to our atmosphere in the distant future. Scientists are studying ways to protect this vital shield. Technologies like carbon capture are being developed. Renewable energy reduces our impact on the atmosphere. Think about it, we can help preserve this protective layer by cutting emissions and protecting tropical forests. Forests absorb CO2, helping balance the atmosphere. Every small action we take makes a difference. Like recycling, saving energy, or planting trees. The atmosphere is humanity's most precious asset. It not only protects us but shapes life as we know it. From nurturing rains to the clear blue skies above. The atmosphere is the very breath of our planet. But it's far more fragile than we often realize. In 2025, we face major challenges to protect it. Climate change and pollution threaten this delicate balance. Humanity must act to keep the shield strong. Rising CO2 drives global warming, altering weather patterns. Methane from agriculture and industry is a growing concern. But global efforts are bringing hope for change. The 2025 Paris Agreement pushes for emissions cuts. Carbon capture tech pulls CO2 from the atmosphere. It helps reduce greenhouse gases effectively. Solar and wind energy are booming worldwide. They replace fossil fuels, easing atmospheric strain. Ozone recovery shows what collective action can do. The CFC ban from the 1980s is healing the ozone layer. In 2025, the ozone hole is the smallest in 40 years. This proves we can make a positive impact. But challenges remain, and we can't get complacent. Deforestation reduces Earth's ability to absorb CO2. Industrialization pumps more emissions into the air. We need to act fast to curb these impacts. Reforestation and ecosystem preservation are key. Every tree planted helps strengthen our atmosphere. Now, let's compare Earth to other planets. Mars has a thin atmosphere, 95% CO2, hostile to life. It lost its atmosphere due to weak magnetic fields. Venus, on the other hand, has a thick, scorching atmosphere. Its CO2-heavy air causes a runaway greenhouse effect. Earth's magnetic field keeps our atmosphere intact. It deflects solar winds, preserving our air. But this magnetic shield is weakening over time. Over millions of years, this could pose risks. Scientists are studying how to safeguard our atmosphere. Satellites in 2025 monitor atmospheric changes closely. NASA and ESA provide critical data for predictions. These tools help us protect our planet's shield. The atmosphere is humanity's greatest treasure. It shapes life, from the air we breathe to rain that falls. But it faces threats we must confront head-on. Together, we can act cutting emissions, planting trees. The atmosphere is Earth's lifeblood, fragile yet vital. It's our duty to protect it for future generations. Every step we take helps preserve this balance. Let's ensure our planet's shield endures for ages to come.